Okay, solving systems of equations using matrices. This is the first example that I'm going to do. It's on the practice test from a previous year. Solve this using matrices and also solve it using Cramer's rule. Note, first of all, however, that we can solve this algebraically using Algebra 2 skills. It's a pretty simple one. We can simply combine the two equations, add them up, the y's go away. We get 5x is 9, so x is 9/5. That's the x value. To get the y value, you would have to substitute this back into one of these two equations. Let me chuck it back into the first one. So we have 2 times 9/5 minus y is 8. And for that, I'll write 40/5 because I'm going to need a common denominator anyway. Right, so what do we get? We get 18/5. Take away 40/5 is equal to y. Move the 40/5 over, the y over. So y is, what's that? Negative 22/5. So this fairly simple, right? Two equations, two unknowns. Using combination, we get x is 9/5 and y is negative 22/5, we said. If we were to graph these two lines, they would intersect at that point. So that would be an ordered pair, 9/5 and negative 22/5. Okay, so that would be the order to the point of intersection of the two lines if we were to graph them. What we want to do is we don't want to use the method from last year. We want to show a new method using matrices. That's the objective of this unit. It's good that we can solve it other ways, but as the systems become larger and larger and larger, the algebraic approach becomes really difficult to do. So matrices or Cramer's rule is the way to go. The first thing we do is we turn this into a matrix equation. So I'm going to have a 2 by 2 here, which is 3, 1, 2, and minus 1. These are the coefficients of the x's and y's, 3, 1, 2, and negative 1. This is just simply going to be the variables, x, y, and this is going to be the right-hand side, which is 1, 8. Now again, just to verify that this makes sense, remember when we multiply these two matrices, we would go this row and this column, so this would be 3x plus 1y, and that's got to be 1. Well, there it is, 3x plus 1y is 1. Second row, first column, 2x minus 1y is 8, that's that. This matrix equation, you can think of it as A times x, we'll use a capital X for the variables, is equal to C. Okay, so we have this matrix equation, and our task is to figure out the x's and the y's. And we're going to do that with inverses. That's the objective of doing inverses. So from a matrix equation perspective, what we want is the inverse of A and the inverse of A. We're going to multiply both sides of this equation by the inverse of A. And matrix multiplication is not commutative, right? So if we multiply on the left here, we have to multiply on the left here. A inverse times A gives us I, right? The identity matrix. And the identity matrix times any matrix X is just going to give us X. So the bottom line here, our matrix, column matrix here, X, Y, is going to be this answer. This is what we want. And so when we work this out, we'll get the same thing we did algebraically. Okay, let's go ahead and find the inverse of this matrix. That's the objective. We'll multiply that on the left and we'll be done, right? We'll get X. We'll multiply it on the right and that will be our answer. So I think we could probably just cut to the chase here and say our xy is going to be the inverse of this. I'll just go ahead and write down 3, 1, 2 minus 1 inverse times 1, 8. And that's how we're going to solve this system of equations. So we've already done inverses once. First of all, let's make sure that this is invertible, right? Because if it's not invertible, there would be no solution. Well, multiplying this way is negative 3. Multiplying this way is positive 3. We subtract negative 3 minus 3 is negative 6. Negative 6 is not 0, right? So our determinant of 3, 1, 2 minus 1 happens to be negative 6, not 0. So we can actually find the inverse. And by the by, that's going to be the denominator when we do the swaps and change the signs, right? So it's good to know that up front. So here we're going to go. We're going to now remember how to find inverses. We swap the elements on the main diagonal. So the -1 goes here, and -1 goes here, and the 3 goes here. And then for the elements on the minor diagonal, we just make them opposites. So -1 minus 2. And we divide everything by the value of the determinant. So we're going to divide this by -6, and we're going to divide this by -6, divide this by -6, and divide this by -6. Now these do clean up quite a bit. So let's go ahead and do that. Maybe I can go over here just a little bit. Okay, so our answer, xy, is going to be the product of these two guys right here. So we have 1/6 times another one's, not times, it's just another 1/6. This is what, 1/3? Because of what we did last time, I'm going to leave it as 2/6 because it may be easier when we do our addition. And this is minus 3/6. So that's going to be my inverse. I have to multiply that times the right-hand side, 1/8, and this will give me my values for x and y. Okay, so let's see how it plays out. Again, this is a 2 by 2, this is a 2 by 1. We know our answer is going to be a 1 by 1. So we just got to get these two numbers. We're going to get this guy, and we're going to get this guy, and let's see how it goes. Okay, so we're going to do a row and a column. So this is 1/6 plus 8/6. One is 9/6, 9/6, 9/6, which is 3/2. Well, that's not right because we already know what x is, right? So we made an error here. Let me go ahead and scratch this video and we'll try again.